For today's class, we are going to examine electrochemistry. And the two words, chemistry deals with, substances, chemicals. No, electro coming from electricity, really. And so this aspect of chemistry, you're going to see a little bit of electricity coming into conduction and all of that. Things that you would have seen maybe in physics or electrical. So we're going to get right into it. One of the things that maybe from your lower school knowledge or even just common knowledge, we would have talked about in your various classes, even if you don't remember, just for safety and other information purposes, basic science, your teacher would have gone through this conductors and non-conductors. So what's really a conductor? Anybody? Anybody knows what a conductor is? We're not talking to persons who, collect the fare on the bus. So what's a conductor?
um Metals that can have electricity pass through.
Wonderful. So I hear you mention metals, but it's not limited to metals, and we may get into some of the examples. Some of the examples you would have known already. So it allows electric current. Oh, beat me for my handwriting. So allows electric current to flow through it. And then of course a non-conductor, it doesn't allow. Jesus Christ, so I'm spelling. Not true. So basically, once you have a conductor, and we see where it is very important, where JPS, the Jamaica Public Service here in Jamaica, they're responsible for providing us with electricity into your home. And one of the things that would be happening right now, you would have been on a device that would have gotten charged through this company, or maybe even if you have solar, but the electricity would have been going through a metal. And later on in the class, we talk a little bit about why metals conduct. But for here, what I want to talk um, really, so conductors, they allow electric current to flow through them. And we're not limiting that to just metals. And then, of course, non-conductors, they don't allow. And just a prime, something that we can relate to, the wire that an extension cord, or even your charger for your laptop or your phone. The plastic, there's a reason why that rubber or plastic is over it. And that prevents you from getting electrocuted because that's a non-conductor. While inside of that rubber or plastic, you do have metal that is there to transmit the electric current. So, so let's go again. When we talk about the things that transmit electric current throughout your chemistry, electrochemistry topic, you're going to be focusing on either, and I didn't say the other one, electrons, or number two would have been ions. And we all know that we have two types of ions, cations and anions. we should know the charges of these two ions. But we said that graphite is capable of conducting electricity because graphite carbon has 4 electrons on its outer shell. In graphite, 3 of those electrons are being shared with other carbons. But 1 electron is actually, we use the word delocalize, or we can use the word mobile. So this electron is capable of moving. And so once it's capable of moving, if you put an electric current on a graphite, piece of graphite, it is capable of transmit electric current. And we said that diamond is not capable of doing that because we are not seeing any electron, any mobile or delocalized. Metals. So our metals, we have that sea of mobile electrons. And so they too, if you push a fork, if you touch a wire that is connected directly to electric current, then you'll be electrocuted because electrons are there. We have that sea of mobile electrons that are capable of transmitting electric current. And we said that we use that as a positive means. That's why our light wires and our other phone chargers and other things that require us to transmit electric current to our small appliances or even large appliances, inside of them we find metals. So that's it for in terms of graphite. Solid. And we have to be mindful of what CXC presents. Even though this is not a CXC question, I always tell students I like this book. This workbook puts you in a position to be able to reason. Now, solid sodium chloride, this is like a table salt. Now, the thing about it, we know sodium chloride. Anybody knows the formula for that? I think what I hear people are shouting out.
NaCl.
Beautiful.
Mm-hmm.
And so we know what happened between these two. Sodium gave away an electron, yeah, to become stable. Chlorine received that electron to become stable. Positive and negative opposite charges attract, and so they form that bond. Here's the thing. This bond is very strong. And when you look, and we did this already in our class, when we look at the structure of a sodium, like a crystal, the ions are held in fixed position. So one of the things is that the ions are not capable of moving. In order for you to transmit electric current, I mean, imagine you have a bus that don't have any wheel and it can't move. Can that do form of transport? I mean, I think the bus can fly. Not gonna be able to do that. So one criteria of you being able to transmit electric current, you have to be able to move. Now, in the structure of the solid sodium chloride, these ions are stationary. They are in a fixed position. They are held in their lattice structure. So they can't move. And so with that, you're not able to have them transmit electric current. So solid, and bear in mind, they would tell you if it is solid or if it is aqueous or whatever. So solid sodium chloride, non-conductor. It's not able to conduct electric current. Copper 2 sulfate. Somebody give me the formula for that. Walk on.
Cu2 plus. No, sorry. Cu
SO4.
bracket 2 plus 2.
Why we say bracket 2 though?
All right.
Remember?
CuSO4.
Yeah. So remember, it is copper 2.
Mm-hmm.
Beautiful. So copper 2, and notice this word, solution, right? And so the solution is what makes it a difference. Never say copper 2 sulfate a solid. So in the solution now, when you dissolve this, probably in more than likely water, what you find is that the ions are now capable of moving. And so once they're able to move, then we have a situation where it's going to be a conductor. Aqueous nitric acid. What is the formula for that? What's the formula for nitric acid? Well, go on. That's acid and base. So nitric would be coming from nitrate. And we know acid, what makes an acid an acid? The H plus. So HNO3, and we have aqueous. Yeah? So the fact that we say aqueous, we should know as a chemistry student, what this means is that, the acid is dissolved in water. Water is a solvent. And so this acid is basically, again, we have our H plus, we have our NO3 minus. That's what it is made up of. And so it will dissociate once you place it in water. Dissociate means to break apart. And once we have them breaking apart and moving around, then definitely we're going to have a situation where we have a conductor because these ions are mobile. I love to do a little throwback. What type of acid is this in terms of monobasic, dibasic, tribasic? Anyone?
For which one?
We're talking about nitric acid.
Mm.
Is it monobasic?
So
Go ahead.
more monobasic
Why?
because they only have one hydrogen ion. Hydrogen.
Beautiful. So once it only provides one hydrogen, so when we look at this compound, this is actually a mole of nitric acid, and out of this 1 mole, we can only get one hydrogen ion. So it's simply, right? And so it is considered to be a monobasic acid. Beautiful. Now, watch this. This is carbon tetrachloride. Who can give me the formula for that?
CCl4.
Beautiful. Now, carbon tetrachloride sound complicated. It sound, hey, carbon tetrachloride. And you sound like you know some stuff. What type of compound is it? And let me help. When I say type of compound, is it an ionic compound or a covalent compound?
Covalent.
Covalent. And so, you see, as a bright student, can you tell me if this is going to be a conductor or a non-conductor?
Non-conductor.
Why do you say non-conductor?
Um, because they don't have. They only have anions, like two non-metals. So they don't have free electrons.
All right, let me fix it up. So you're on a correct path, but I love the reasoning. So we know covalent really deals with non-metals and they're sharing. And the fact that they're sharing, we don't have ions being formed. Remember over here we said there are two things that help us to transmit electric current. So as you said, those electrons would be shared, right? So just like right here, where you don't have any that is basically loose, like in graphite. All of them are being shared. And so we don't have any ions because it's a covalent compound. And so there's nothing there to transmit the electric current. So carbon tetrachloride is considered to be a non-conductor. Not true?
Yeah.
Now sulfur. Reasoning again. Is sulfur a non-conductor or a conductor?
Non-conductor.
So it's a non-conductor. And again, sulfur is really a non-metal. And we know one of the properties. Let me just say this. When scientists are discovering elements, and they would have classified elements on the periodic table basically into two broad categories. Either they're non-metals or metals. We have the metalloids, but still metals. Yeah. Um, we use the concept of, is it capable of transmitting electric current? And so all non-metals would have not been able to. So one criteria that we use to, decide if a substance, if them find a new element and them say, well, the element that can transmit electric current, then it's going to go over to the metal side of life. So this would have helped you getting warmer in terms of electrochemistry, getting deeper. So we would have, under anybody who has any issues with what we have discussed so far, anything you want to clarify or clear up moving forward. Yeah. So they bring us to this term. So what is an electrolyte? So an electrolyte is really a compound that basically supplies ions. And these ions are going to be formed when they're either molten or aqueous. So in order for it to provide these ions, it has to be molten or aqueous, right? Because the thing is, when we go back and we look at when we were talking about the sodium chloride, one of the things that would have been happening is that the ions are in a fixed position. So if this had said aqueous sodium chloride, then we would have to consider it to be a conductor because now the ions are able to move. If they had said molten sodium chloride, again, we would have to select conductor because the ions would have been able to move. Yeah? Now, the next question says, distinguish between a strong and a weak electrolyte. Now, remember we said that this is a substance that is going to be providing ions, right? So the more ions you provide in the solution, the stronger or the capability of you transmitting electric current is going to be greater. So a strong electrolyte is one that dissociates completely. So when they basically, if you have a electrolyte and you melt it, or you place it in a aqueous solution, or you place it in water to get that aqueous solution, and it dissociates completely, meaning all the ions are available, it would have been considered to be a strong electrolyte. Now, oftentimes when we go back, taking a throw back again, so we talk about strong acids and strong base. A lot of times we are putting that concept to an acid that maybe, when you talk about concentration, the amount, no, it is based on the amount of hydrogen ions that it provides. And so one thing coming across over to our electrochemistry, those acids that are weak are going to become weak electrolyte. So give me a weak acid, one of the popular weak acid that we know. Hint, we use it in the kitchen sometimes when we cook.
Hydrofluoric acid.
No, you're crazy.
Vinegar, ethanoic acid.
Vinegar, hydrofluoric acid is very, very much strong. So remember, fluorine is one of the strongest non-metal. So you have to be mindful of that. The vinegar, ethanoic acid, is a weak acid. So it's going to be a weak electrolyte because it doesn't ionize completely. And you hear the word ionize, meaning to form ions. So it doesn't form a lot of ions. Unlike something like sulfuric acid, unlike something like hydrochloric acid. Now, bear in mind, another mistake that students will do is to think that the monobasic and the dibasic has something to do with the strength. No. Again, even though this is a dibasic acid, sulfuric acid, and this hydrochloric acid is a monobasic, both are considered to be strong acids. Why? Because they dissociate, they break apart completely when you place them in aqueous or place them in water. So you get in all of those hydrogen ions and the sulfate ions, all of those hydrogen ions and the chloride ions. So both of these, they will also form strong electrolyte, because as we said, strong acid forms strong electrolyte. Weak acid forms weak electrolyte. Because again, what is it that is allowing you to quantify or put the electrolyte in a strong or a weak category is the amount of current that it can transmit. What allows for the current to be transmitted in an electrolyte? The amount of ions present. So if they break apart completely, then you will have enough ions to transmit that electric current. Right? So the more ions, the more current that can be transmitted. Yeah? All right. So why is pure water classified as a weak electrolyte? Now, the thing about pure water, so if you go back to the weak electrolyte here, we said that the weak electrolyte will basically break up or dissociate partially. So we use the word completely for strong, partially for weak. Now water, when you examine water, what's the formula for water?
H2.
Beautiful. So we know water can be represented like this as well. So it is there where you have hydrogen ions and you also have hydroxide ions. The thing about water, just like with the vinegar, so when you have these ions, they don't stay as ions in the water. They go back to being the covalent compound, which is this. So remember, in order for the electrolyte to basically transmit electric current, we need these ions. So if you have water, water will basically be like this, but at the same time, most of the molecules will go back to this form. And so, due to that, there's not a lot of ions. So it's weak, there's no ionization in terms of water. And so there's not a lot of ions to transmit that electric current. So water is classified as a weak electrolyte. Yeah?
There's not a lot of what?
There's not a lot of ions because the ions will combine to form back the H2O. You see, like when you basically have HCl, the ions are separated. So them break apart now and you have them floating around. But when you have water, water really forms the molecule. So they are there, and we know a molecule is a term used for covalent compound. And as we said before, covalent would not be able to be a good conductor because they don't have any ions. There's no ions to transmit the electric current. So water is considered to be a weak electrolyte, even though you will have some hydrogen ions, you will have some OH ions, but they are in low concentration. You don't have a lot of them. So the ions are in low concentration. Cool? So pure water, and if you notice why we say pure water means that we only have H2O. So if you have a water now, like tap water, you might have potassium ion, you might have other sodium ion, calcium, other ions that are in the water. So don't get it twisted. We are talking about pure water. Remember, pure substance is only made up of one type of material. So you're only finding the combination of H2O in pure water. But water that is not pure, you may find other ions that are present. And if you have other ions, then it's going to be capable of transmitting electric current. So pure water, not capable, or it is very weak. Can transmit, but it's not as strong as if you had water that has impurities in it, where you're going to have other ions that are present that will be capable of transmitting the electric current. Yeah? Any question? So, really and truly, when we're going to, how is this application going to be in chemistry? What is the real influence that it has? No, electrolysis. And I'm going to give a little background. Say, for example, sodium, again, reacting with chlorine. And even though I might not write a balanced chemical equation, we get sodium chloride, right? Let me balance up and put in, yeah. Now, it all comes back to the story about what is happening here. We said that sodium has one electron on its outer shell. Chlorine has 7 electrons. Now, both of them want to become stable. And so, to become stable, we know that metals who have 1, 2, or 3 electrons on their outer shell, they will lose those electrons. Nonmetals who have 5, 6, 7 will gain electrons, or they can also share. But this is ionic bonding, so we're basically looking at a metal and a non-metal here. This caused them to become ions, and then they form the compound sodium chloride. Remember the positive cation, negative anion. Now, in reality, again, and I'm using this example, you're doing the chemistry to pass it at the CSEC level. Think about this. If when you do the chemistry in a May coming, and you get a 1, and you get a 2, would you want to lose that 2 September coming and you have to do it over next year?
No.
So, because that, when you acquire the subject, it's like it's going to help you. Maybe you're doing it to further your education in terms of getting into a college, getting a particular increment on your pay or something along that line. So you getting the subject, you don't want to lose it. Why am I doing this comparison, or why am I speaking about that? Sodium and chlorine went into this bonding, and so both of them will not want to go back to that state where they are again unstable. You know, you buy a house, you buy a car, you get the subject. You don't want a time to come and you have to lose all of that and you have to start over. So sodium and chlorine will not want to revert to being sodium alone and chlorine alone, where they're lacking. One of them more and get rid of that electron here, the other one more and gain an electron. So they will stay like this forever unless they are forced to do otherwise. So if you want to get sodium by itself in chemistry, or get chlorine by itself in chemistry, you can do a process known as electrolysis. So it's going to be where you're going to pass an electric current through the substance and allow it to break down. So when you pass the current through sodium chloride, what it will do is to break apart into sodium and chlorine, and you get back those 2 sodium chloride. So if you check history, you can have sodium chloride in your cupboard. You can have salt in your cupboard for months, for years. And you go there and nothing happen. It's good. So that is the whole point of electrolysis. And so everything that we've discussed, we're going to be putting it into play to understand the whole concept of how can we obtain the sodium and the chlorine by the passage of electric current. Now, we spoke about two or even if we never talk about it, there are two types of conduction, metallic. And once a year metallic, we're dealing with what?
Metal.
Metals. What did I say transmit the electric current in metals?
Ions and electrons.
No, in metals. So overall, ions and electrons are responsible for conducting electric current. But which one is responsible for it in a metal?
Mobile electron.
So the mobile electrons. So really and truly, I didn't read this, but let me read it for the benefit. Complete the table below to give two differences between metallic conduction and electrolytic conduction. So in metallic conduction, electrons are responsible. The current. So who is responsible to transmit the current in electrolytic conduction?
Ions.
So we have the ion. So that's one difference, guys. So in electrolytic conduction, ions are responsible for transmitting the electric current. In metallic conduction, electrons are responsible. The other difference though, when the metals conduct electricity, they aren't changed. Meaning, I mean, you don't have to go there and replace the metal because all it is doing is really conducting the electricity. It's unaffected by the passage of electric current. But in electrolytic conduction, and that's why we said the electrolyte is going to decompose. So it's going to break down. And that's why we said that, we use the whole concept of electricity, electrolysis to break down um, compounds, ionic compounds. So the two differences are in metallic conduction, electrons transmit the electric current, while in electrolytic conduction, ions transmit the electric current. In metallic conduction, the metals aren't changed, while in electrolytic conduction, the electrolyte breaks down, it is decomposed. Cool? Yeah? Electrolysis, so it is the process where you break down a substance by the passage of electric current. So when you do electrolysis, you basically use an electrolytic cell, and we're getting into that right now, where you have the passage of electric current. And so what you really have is that there's a chemical change in the substance. And that chemical change in the substance is due to the the passage of the electric current. That's why this topic is called electrochemistry. As I said before, you're really dealing with electrical or electricity and chemistry. How is this applied? We're going to even get into the concept of that. Electrolysis is a very important. There are industrial applications of this method. So, I don't want to call nobody name. I don't call somebody name, but I'm not going to do it. So, one aspect is, in a Jamaican terms, we say wash over gold. You ever hear that term there yet? You ever hear the term wash over gold?
Yes, sir.
Yes, so really and truly, the wash over gold is where they just use another metal, but through electrolysis, they actually coat that metal with a thin layer of gold. So not all of the item is gold. It's just a little thin strip they place over it. And electrolysis, a lot of you don't know, it's chemistry. So when you have your nice chain that is not fully gold, but yeah, it has a thin layer over it, right? So it makes it more attractive. Yeah, that's one of the process, or that's one of the application. And we're going to get down into that later on. Maybe not this class, because it's going to have to be a two-part. The other application is when you talk about I don't know if you know these windows. So when you have those nice aluminum windows that don't rust, electrolysis coming into play again, because a part of it we utilize the aluminum. Aluminum, and we're going to get into that, has a property that when it reacts with oxygen, it actually makes it stronger. Unlike when it reacts with iron, it forms that rust and it flakes off, and you see that little red thing on your fingers or your hand when you touch against it. On the flip side, they recognize that oxygen, when reacting with aluminum, it makes it stronger. And so that's when you have your aluminum windows and doors and those things, you don't have to think about painting it. You can just allow it to stay because of the process of electrolysis. And finally, we use it to purify metals. So if you have a metal that having impurities, you can use electrolysis to purify that metal. Yeah? Right. So I spoke about the concept of electrolysis, and we said that one of the things that needs to be happening is that you need an electrolytic cell. Now, an electrolytic cell has what we call electrodes. And electrodes are basically substance or metals rather that will bring, and I'm going to go down to this diagram right here, that will bring electric current into and out of the electrolyte. So again, we're looking at the electrolyte here. So we'll have a discussion. And so one of the things that you're going to have to understand about the electrolytic cell is that you have two different electrodes, one called an anode, one called an cathode. Now, the anode, this is the electrode that is positively charged and connects to the positive terminal of your battery or your power supply. So when you see like oh we have this diagram and they're going to be asking you certain things, you're supposed to, even if them turn the diagram upside, right side, left side, upside down, wherever they want to construct the diagram. One thing that you will be able to use, because both of these, when we talk about the electrodes, see them here? These are the two electrodes we're talking about. They are the ones that will take current out and put current in your electrolyte. They are the anode and the cathode. They don't have to be oriented on any particular way. In other words, and even though I tell students that I am used to most of the time drawing the anode on the left hand side, but the anode can also be on the right hand side. But due to continually drawing the diagram, explaining in classes, I normally do it on the left hand side. But don't get it twisted. The anode is not limited to, say, left and the cathode limited to right. What you should use is which side of the power supply it's connected to. So to know the anode, you look where it is connected to the power supply. If it is if it is the anode, then it must be connected to the positive terminal of your battery. Cool?
Yes, sir.
And so the cathode negatively charged and it is connected to uh, the negative terminal on the battery or power supply. Now, watch me now. Look at this area right here, so. Because if you do a little bit of physics, you may know. But the area where have the long, notice this, this is what I wanted to note, versus the short. So for the long, just like, when you take out your battery, when you look at a battery and you see that little bump, yeah? We know the little bump on the battery, guys.
Yeah, yeah.
We now talk a car battery, regular battery, AAA, AA. Right there is the positive. So the longer side is your positive. Because students may ask me, but sir, I'm not seeing a positive or a negative here. But you should know this. When you see this long line, it represents the positive. The short line represents the negative. So right away, when you look at W, W would be what? W would be what? We're not seeing it.
Cathode.
Can't be the cathode. What did we say? Which side is the cathode connected to?
Negative.
All right. Which side did we say? So see it here? This side is the short side. So this is negative.
Oh, okay.
This side has the long side. So this is the positive. So W would be the,
Anode.
and so again, guys, let me emphasize this. It doesn't mean that the anode is always going to be on the left hand side. It doesn't mean that the cathode always will be on the right hand side. For me as a teacher, normally me draw it like this, but it doesn't have to be presented on a paper like this. What you should know is that if it is the anode, you're going to be seeing it. So some diagrams may label the positive and the negative, some may not. They may give you this symbol that represents the power supply, the power source. And you know that the longer side is a positive, shorter side is the negative. So what is Y?
Cathode.
And bear in mind, I jump this particular question, right? And we're going to examine. Now, I should have started this topic by explaining that just like in a situation, if you don't do CSEC chemistry, you're going to have a challenge to jump and do Cape chemistry or even go on university chemistry. And so those are considered to be prerequisite. So if you're going to be joining a CAPE class, not that you can't, but even as a student, if you haven't done any CSEC chemistry and you're going to a CAPE class, then you have to go and do some reading because CSEC chemistry is a prerequisite. Your teacher would be coming to expecting you to know certain things. So to know electrolysis, and we have done this, oxidation and reduction is going to come back. So you have to have an understanding of what oxidation is and what reduction is, because you're going to be asked question and see one here coming right away. Why does oxidation occur at the anode and reduction occur at the cathode? And I'll soon talk about it in a little while. So I'm just going to let this part sink in, going back where you have the anode, where you have the cathode, and we're supposed to be smiling and understanding. Anybody who is here and don't understand how we get this to be the anode and the cathode? So I'm gonna talk a little bit about this. So to answer this part of it, I'm going to deal with the diagram. So it says the diagram below shows the electrolysis of molten. What does that mean? It means that we melt the thing. We melt it. If we say molten versus aqueous, molten we melt, aqueous we do what?
Dissolve in water.
Beautiful. And so one of the things that you have to highlight in this concept of electrolysis is what type of electrolyte. So this right here is the electrolyte, molten lead bromide. Now here's the thing. Remember we learned this. If it is that we just put the solid lead bromide into the electrolytic cell, nothing will happen because just like sodium chloride, lead bromide is an ionic compound and the ions will be stable. What's the formula for lead 2 bromide?
PB um BR2 or PB. Huh?
I want them to allow you to If you mess it up. I would say the right thing. What were you going to say?
Nothing.
All right. So lead bromide, again, as a chemistry student, if you don't know how we got to this, remember the lead is a 2 plus, bromide is a minus, and that's how we come up with that formula. So we have to, again, so another thing, that is a given. You have to know override formula, because they never give you right here, so. But it is interesting that they say that they melt it. So we now know in our electrolyte, I can draw a few right here. We have Pb2 plus and we have Br minus floating around because they would have now been loose. They can move, and that's what we want. Yeah? Now, going back to what I said. So if I want to get back the lead, if I want to get back the bromine, I can pass electric current through this substance and it will cause it to break apart. Let's make the connection now. Why did the anode become positively charged? You see, when you turn on your system, electrons are going to be pulled from this electrode. And as a student, you're supposed to say to yourself, or you're supposed to can make this connection. You remember with metals, what do metals do? When them lose electron, they become positively charged, not true?
Yeah.
So when the electrode on this side, when you turn on the system and it starts to pull electron, it becomes positively charged. Follow me, you know. And as we said, one of the reasons why, it's connected to the positive side of the battery. So it's pulling electron. The negative side, electrons are being pushed onto this electrode. And we can think to ourselves, remember even with sodium chloride, when chlorine get the electron, it became negative. And so when this electrode gets electron, it becomes negative. Follow so far? So that's where the positive and the negative charge of these electrodes come into play. Watch me now. Remember, we have those ions floating in our electrolyte. These ions also have a charge. So because this is positive, it attracts the negative. What do we call the negative ions? What do we call a negative ion?
Anions.
Anions. And so sometimes students are baffled, but look on the connection now. Anion coming from, see there? Anode. So you should know that the anions will migrate towards the anode. Also, they are migrating over there because the anode has that positive charge, and we know unlike charges attract each other. So the lead now go over there. Because the lead positive. Positive and positive, we not deal with that. So the bromine ventures over there. Because the bromine say, yeah, well, one positive charge over there, so, you go over there and so on go on. But let's go back to this compound. Lead would have had the 2 electrons, right? And lead did what? Give up those 2 electrons to one bromine, get 1, another bromine would have get 1. Not true? True? Work with me now. So one bromine will I get one electron. See there, that's why the lead became a 2 plus, because it only way it would have come a 2 plus because it has lost 2 electrons. So when bromine come over here, you know what the anode do? It's going to do what? Who can figure it out? What is the anode going to do to the bromine? So the anode takes back the electron that bromine got. Because again, the whole point of us doing this is to get the bromine by itself and the lead by itself. And so we want to get them back to how they would have looked on the periodic table. So the bromine lose electron. Follow me now. Watch you now. Watch the connection. Which bright student can tell me what is the loss of electron? What's the loss of electron, guys?
Oxidation.
Oxidation. So, as I said before, I'm coming to the answer to this question, but I did a little explanation down here. So right there and then, bromine is losing electron, and so oxidation occurs at the anode. So at the anode, oxidation occurs since ions lose electrons. Everybody following so far? I'm gonna do back a run through. So simultaneously, so this right here, this X would have been the bromine. A matter of fact, we know that bromine is one of the 7 diatomic. So when one atom of bromine gets the electron, bromine atom now go just stay so in nature. It will go look for another bromine atom. So when another one lose the electron, they form the bromine gas. And so the bromine gas, the bubbles that we're seeing right here currently on this is the gas being emitted. We would have referred to that as being effervescence. So we're seeing that gas, seeing bubbles, right? So that indicate that the gas is being given off. Now, as I said before, for electrolysis, what we want to do is to get back. So I want to get back the bromine gas. What I will do is to have a collection system here. So as the gas is being emitted, I can collect that bromine gas. Jumping over to the other side of life. And I didn't talk about this A right here. We can use an anemometer to judge the amount of current that is flowing, right? Sometimes we put a bulb. So you see they do something like that to indicate a bulb. Yeah? And so what they will sometimes ask you is that which one of them a strong electrolyte or a weak electrolyte, which one will cause the bulb to be brightest. Definitely, again, going back to what you would have known, the strong electrolyte will allow for more ions to be in the solution, which means more ions can transmit more electric current, which means the bulb will shine brighter. So them love ask you where they may put even vinegar. So then we say ethanoic acid as the electrolyte versus sulfuric acid or copper sulfate solution. Which one of them is a stronger electrolyte? You should know. Or which one will make the bulb brighter? Yeah? So electrons are being pushed onto this electrode. When electrons are pushed right here, it causes it to become negatively charged. So it gets electrons, and so it becomes negatively charged. Who does it attract? The positively charged ions. What do you call the positively charged ions? They're called
Okay.
cations, and such the name cathode. I hope you're making the connection, because it's not far. So sometimes we just hear the name them, see the names, and we just think that it's. So this right here is really related. So the cations are positive, the cathode is negative, so the cations are going to migrate. So lead is going to say, hey, what's happening over here? Let's go investigate. Something is pulling me. Something is pulling me to this side of the electrolytic cell. Let me go and investigate. Yeah, somebody saying something? So when lead come over here, so what lead did do? Lead did lose 2 electrons. You know what the cathode do? Force lead to get back those electrons. And if it forces it to get back electrons, what is the gain of electron?
Reduction.
And so reduction happens at the cathode. And so this cathode in particular, you're going to be seeing evidence of the lead being deposited, right? So you're going to have the molten lead here. So see it there? So on one side, we have the bromine. So we're just going back to the definition, going back to what we want to do. Lead bromide will not break down naturally because the lead and the bromide are comfortable because they are stable. But if we want to get back the lead and the bromine, we can go through the process of electrolysis, where we're going to be passing an electric current through the substance to break it apart. Now, bear in mind, in order for electrolysis to work, the electrolyte that you have has to either be molten or aqueous. In this question, we're using molten. And there's a difference because there are certain things that will allow you. There are 3 things, and I didn't highlight it as well. See it here? Look at this. They say that the electrodes are made out, they are using inert graphite electrodes. And again, we just learned today, or we would have gotten the explanation today, why graphite would have been the substance or the material that we use to make the electrodes. Because graphite is one thing that it's a conductor. It can allow electric current to pass through it. So later on, there are 2 types of electrodes, active and inert. Inert electrodes is when you use carbon, like graphite, and active, we're going to discuss that later when it comes up. So we're following so far. So why I mention it, there are three things that will eventually allow for which ions are sent to the cathode or the anode. Because in this case, we have only two sets of ion. In another case, where we're going to see examples, you're going to have more than one ions, and only one ions is, and let me use the word, discharge at each electrode. And we have some criteria that we use to figure out which one will be selected. So let's run through. Once I put my molten lead bromide, the ions will be floating around. I turn it on, my circuit. It's going to pull electrons from this electrode. Electrons are pulled, causing it to become positively charged. Electrons are sent around in the system. The ammeter records, the current that is passing through. So if you want to know, you can jot that down as a student doing the experiment. Also, electrons are forced onto this electrode, causing it to be negatively charged. This is your cathode. Now, the negative and positively charged being given off by the anode and the cathode will basically pull the different ions in the electrolyte. So here, the anode is positively charged, so it will pull the bromine ion towards it. When the bromine ion comes towards it, the anode is going to pull electrons from the bromine, causing it to become back the bromine atom. We know that bromine atom is diatomic, one of the 7 diatomic elements. And so that bromine atom will find another bromine atom and bond with it quickly, forming the bromine gas. Now, the loss of electron is considered to be oxidation. So oxidation always happens at the anode. On the flip side, we have the lead moving towards the cathode. The lead would have given up 2 electrons, to become stable. When it goes against the cathode is going to force it to accept 2 electrons, forming back the lead, the molten lead. That is what is deposited on this cathode. When you gain electron, that is reduction. And so reduction always happens at the cathode. In some cases, and later on you're going to be looking at those questions, they will structure your questions in terms of saying you can take the weight. You can take the weight of this cathode before you start the electrolysis process, and when you finish, you can check the weight again to see how much, what's the mass increase, and that will tell you or determine how much lead would have been deposited. And so right here, guys, electrolysis sometimes includes moles. So what the question will do is ask you about the volume of gas. So they can ask you about the volume of bromine being given off here, and you know that relationship. They can ask you about the moles of lead. And we know we can convert the moles, the mass that we get, to moles. They can ask you about the moles that is given off, and you can use that to convert. So later on, we're going to be doing that calculation. So moles will come and haunt you if you don't understand this concept writing this question. Yeah? So we would have labeled W, X, Y, and Z on the lines provided on the diagram above. Any questions right here? Now, again, coming from oxidation and reduction, we are supposed to write ionic equations to show the formation of X and Y. Let's go back. X would have been the bromine, Y, Z or Z would have been the molten lead. Let's go. So when you look at the bromine, and you have to be careful here. Cannot use aqueous. Have to use a liquid because we use molten. Remember, we never dissolve the bromine in any water, so we can't use aqueous, yeah? The bromine ion became the bromine, who can tell me? What did we say we call it?
Gas.
The gas, yeah? Watch me now again, guys. Watch me keenly. We have to balance the equation. So see it here, we have two bromine atoms that forms this. We only have one bromine ion. So to balance, we have to put a 2 there. Yeah? Let me go back to this. I showed persons this when we did oxidation and reduction. I'm going to bring it back right here. So we say reduction, we write the electrons on the left-hand side. Oxidation, we write the electrons on the right-hand side. What did we say happened at the anode? Because this is for the anode, not true?
Oxidation.
So where am I going to be putting the electrons?
On the right
On
hand
the
side.
right.
On the right-hand side. Here's the next thing. How many electrons are we talking about? How many electrons? How many electrons each bromine atom needs to become the bromine ion?
2.
One.
I said each, so it would have been 1. So
Oh, each.
if you have 2 in total, we know we need 2 electrons. So plus 2 electron. Yeah? And I want to do something right here before me even go into the calculation because you can learn it from this point. Remember, we talk about moles in chemical equation, mole ratio, very vital here. So if I want to get, look at it, 1 mole of bromine gas, I need 2 moles of electron. I also would have had 2 moles of bromine ions. So that's that relationship. Please remember that relationship so that we understand. So every 2 moles of electron, yeah, I require or I can obtain 1 mole of bromine gas. Let's do the lead. So lead, Pb, 2 plus, liquid, becoming lead, liquid, right? What happens at the cathode?
Reduction.
And reduction, we write the electrons on the,
left,
Left-hand side.
so we have plus, how many electrons?
plus 2,
2 electrons. And again, we can use our mole ratio to evaluate. So if I want to make a comparison, every 2 moles of electron, right? And later on, you're going to see the relationship between the electrons and the current, because there's a relationship between how much current the electrons can carry. So 2 moles of electron can give me 1 mole of lead. And I said to you that sometimes what they will do is to bring in moles. So if I'm getting moles of lead, I can use that to determine the mass of lead that will be deposited. If I'm getting moles of bromine gas, I can use that moles to work out the volume of bromine gas. So that's how they will come at you with that question. Cool? Yeah. Next thing, now, you see, because sometimes we have more than one ions present, and that will determine who gets preference. So you might have a situation, I don't know if I can jump the gun, but if you had instead dissolved the lead bromide, for argument's sake, in water, you would now not only have lead ions, you will also have present hydrogen ions. You wouldn't only have bromide ions, you would also have hydroxide ions. Bear in mind, I put them in categories. The 2 anions are there. We have the 2 cations. And so only one can be discharged. Why am I mentioning all of that? Because it goes back to your electrochemical series of metals, you know. It can be used to predict various chemical reactions. So how metals are arranged in ease of becoming ions, right? Step order. Let me use that word. And some persons have a little jargon. I'll share my jargon to basically explain later. But really and truly, based on their ability to become ions, that's how we put them in our electrochemical series.
What's that word? In order of?
Ease of which they become ions. So metal F, here's the thing. Metal F is above zinc in the electrochemical series. Would you expect F to react with zinc sulfate solution? Give a reason for your answer. So would F, the series, sorry, this is supposed to be iron, then lead. And some of them, some of the series, you may see them add other metals. But again, so we're saying the zinc is here, F is above zinc. So what do we know? We know F is more reactive. So what will happen when F comes along and see the zinc bonded or in a solution of the zinc sulfate, what F will do, since it is more, reactive, it's going to cause zinc to lose that bond that it has with the sulfate. So it's going to, and we call this a single displacement reaction. So a lot of times we don't really, some teachers, even myself, may not sit down and say, I'm going to teach the types of reaction, because as you go through the syllabus, you are exposed to the different types of reactions. So this one is a single displacement reaction where, since the F metal is technically higher in the series, it is capable of displacing the zinc. Yeah? So we will end up forming F sulfate, and the zinc would be over here by itself. So whatever F was. So F could have been the aluminum, the magnesium, the calcium, whichever one that is above the zinc. Cool? So when you have a more reactive metal, since it is easier to become an ion, it's going to become an ion in the solution, then it's going to discharge, cause the zinc ion to be discharged. Yeah? Metal G is below hydrogen in the electrochemical series. Would you expect G to react with hydrochloric acid? Give a reason for your answer.
I'm sorry, sir. Can you repeat the one for metal F? It's more reactive.
So metal F, it ionizes at a greater extent than the zinc. So once you put it in the solution, it's going to become an iron easier. So when it becomes an ion easier, it's going to discharge. So the zinc ions that are there, it's going to discharge them, causing them to basically lose that bond with the sulfate, forming the zinc solid, going back. So it's, in other words, it is causing the zinc to go back to its atom state. Because bigger bother general forward, general F. Yeah? We have a concept. I wonder if I can use this concept. Because normally I put up my videos them on YouTube. So say for example, you have a female that is attracted to males that have cars. So while you have that sulfate and that zinc being present, now the sulfate is going to want to bond, and the sulfate here is a representation of the female. The sulfate would want to bond to the one that is more easier to ionize. So if it is that the female prefer, a person with a nicer looking car, and I'm just using this as an example. Oh, the females are not kill me later on. So, in Jamaica, Markex is Bima, Audi, those type of vehicles are considered, classy vehicles. While if you drive, and it depends too, but I'm just saying, if you drive a Pro Box, you might be looked down on. So she's with this Pro Box guy, right? And so a Markex person comes along, or a Bima. So what is happening? That type of car is going to be more attractive to her. So it's the same thing. The F, in this case, ionize more easier than the zinc. So the sulfate now go on the problem if you get the ion, the electrons them from zinc. Cause whole heap of trouble that, So if you have a element that will give you, sulfate needs the electrons. If you have an element that will give you the electrons much easier that comes along, we're going to take it from that element. Zinc can go in ways. So zinc, go on your ways. We'll take the electrons from F. Cool? So that's really what happens. So in this case, we have a similar case, but in this, we're talking about somebody, metal G is below hydrogen. So G, whatever it is going to be reacting with hydrochloric acid. And the question is, we're not going to have that reaction. The G, as we said, too harder for it to lose that
Right.
electron to become, something of any benefit to the chlorine. So the chlorine I gonna say, yeah, what? Me go and chill with the hydrogen. You can't stay there. Me not no time for wait for you ionize. Hydrogen right now is above you and then we ionize much easier. So I'm not going to, because remember, even if you look at it in this way, chlorine want to be stable. So if for example, and if this is possible, you go to a class for 8 months to be able to pass the chemistry versus you can go to a class for 2 months and pass the chemistry with the same grade. Which one of the class you go to?
2 months.
2 months, because you really value the time. So if you're in the class for 8 months and you're here, say you have a class where you can go to for 2 months, more than likely you probably leave that class and go to the 8-month one. Any. All right. So the metal G, as we said, it's not that it's below. So it's going to find it harder to become ion, because you becoming an ion as a metal really is a reflection of your reality, your reactivity, right? And so if you can give up those electrons, because the non-metal, Mr. Chlorine, right? So non-metals, them love electron, they're electron loving. And so if G would have been able to give up the electrons much easier than hydrogen, then yes, they would have, the chlorine would have taken up the opportunity. But G, no sir, you're below. So more than likely copper, silver, gold. And we're not depend on that, right? I know it's past 10, but just give me 2 seconds. Let me just deal with this last question. So it says, write an equation for the reaction between magnesium and copper 2 sulfate solution. So magnesium, all metals are solids at room temperature reacting with copper 2 sulfate. So we know that, again, we should know. So I was saying that I have a little jargon. In the electrochemical series, really and truly, the copper, sorry, not the copper, the calcium comes before the sodium. This is supposed to be sodium. Nobody not tell me if we put the A. I don't know, so the video get put out. Anyway, so the calcium is above. When you're talking about the reactivity of metals, sodium is above calcium, right? But in the electrochemical series, the calcium is above sodium. So we say Kemar could not, because we're saying in the electrochemical series, calcium would have been above sodium. So Kemar could not make any Zurich football league. So even though we have PB for lead, lead is L, so league, how could Andre Austin? Kemar could not make any Zurich Football League. How could Andre Austin? And we just use that. I'm going through the whole high school system to remember the reactivity series. You can, and I did another one. If I find it, I can share it, that I used to, you can make up your own little jargon to remember the electrochemical series, because that's going to be needed. So if you have the series, you'd have recognized that magnesium is way above copper. That means magnesium is more reactive. It is going to be much easier for it to become an ion than copper. So if it meets up with copper and copper is with another compound in our solution, it's going to displace the copper. So what would we get? What would we get?
Magnesium sulfate.
Mm.
And of course, we are going to get
Copper.
all right. Let me show you something again, and I'm going to do it quickly. So again, even with this, even with us talking about electrochemistry, we can go back to types of reaction. We can talk about balancing equation. We can talk about ionic equation. We can talk about moles. We can talk about oxidation and reduction. So questions, you have to have the ability to incorporate and know that each topic is not, even though we teach you by topic, some of them are interrelated. Once you're going to be writing equation, you're supposed to write a balanced chemical equation in CSEC. Once you're writing an equation as well, we're supposed to be seeing state symbols. So things like that will help you out. All right? So again, we will continue. We're going to then talk about the whole preferential discharge in part 2 and look at other examples and the application of electrolysis. So I hope it was beneficial. Go back through the information, and then of course when we're through we can tackle some past paper questions, or you can even start looking at some past paper questions regarding electrochemistry. So that's it. All right, so list the 3 factors that affect the preferential discharge of anions during the electrolysis of aqueous solution. And if you notice, it singles out the anions. So one of the things that affect the preferential discharge of the anions is the type or nature of electrode. The next thing that will influence the concept of who gets preferentially discharged is the concentration of electrolyte. And finally, the electrochemical series. And so these are the 3 things to consider when you're going to be dealing with which anions are sent to the anode. So again, I hope this video was beneficial. We want to give a shout out to Elite Detailing, again located in Portmore. If you want your cars, your vehicle to be smelling fresh, they're on Instagram, they're on TikTok, they're on YouTube. You can search Elite Detailing and make your book an appointment for your car today. We want to give a shout out to D&J Document Center. You can contact them in terms of your printing, whether photos, documents, binding, scanning, laminating. They would surely help with your preparation of documents. And of course, Graphics Photo Studio. Property tax. You can pay your bills. You can take your passport size photos. You can do even fitness. payment fee. So again, you can contact them. They're located on St. John's Road, 68 St. John's Road, Spanish Town. Do enjoy the rest of the day, whether you're watching this in the night as well. Remember to like, subscribe, and share the video. This is Mr. Thomas, Buckle Down Tutoring Services. That's it.